Alright, for today's lesson, we are going to be working with section 9.1, which is on circles. 9.1 also talks about parabolas, and then 9.1 through 9.3 are about your conic sections. So I'll talk more about this after spring break when we get back. Before we actually begin, you need to do these two problems. So go ahead and pause and do these two problems to review from your Algebra 1 days. So the first question asks you to find the midpoint of a line segment that has 2 points, 8, 3, and 16, 7. So you need your formula in order to be able to do that for midpoint. And so you're going to add the x's and divide by 2, add the y's and divide by 2. And so the midpoint of these 2 points then on this line segment is going to be 12, 5. Number 2 says find the distance between these 2 points. So that one you're going to use your distance formula. It's going to be subtracting your x's, squaring it, plus subtracting your y's, squaring it, and then taking the square root of that sum. So if you do that on these 2 points, the distance between these 2 points is going to be 13. So those are 2 formulas that you are going to have to remember for this unit. So as I said, more specifically, we're going to talk about the circle. So you can pause here to write down the definition. It is a set of points that are equidistant from a given point in the middle. They have the same radius all the way around, and the center is that point that we're talking about. The standard form that you should remember from your geometry days is going to be x squared plus y squared equals r squared. This more specifically has a center of 0. And then, for example, if I have an equation like x squared plus y squared equals 25, what that means, any point on the outer rim of this circle is going to be applied to this formula, x squared plus y squared, and when you do that, you will get 25 every single time. So if you were to do that, for example, with negative 4.68, 1.76, plug in x, plug in y, you will get 25. Same is true for 3.3, 3.756. If you square the 3.3 and you square the 3.756 and then you add it, you will also get 25. So that's true for any point that lies on this circle. Now, if you want to move the circle, the center of it, by moving it right or left, your transformations rules that we learned in Algebra 2 are going to apply here. So x minus h squared is actually going to move it either right or left, depending on the value of h. And then y minus k is going to move it up or down, depending on the value of k. We'll come back and talk about the general form of an equation of a circle later. So I'm going to skip this slide. And so now we're going to do a few examples. So the directions say to find the center and the radius for each circle given these equations. So in letter A, using that formula that we just saw for transforming the circle, we've got x minus h here, so therefore h must be equal to 3. This is technically y minus negative 1, so k has to be negative 1. So if the center is h comma k, that means my center this time will be 3 comma negative 1. And then my r squared is my 16, so therefore r has to be equal to 4. Easy peasy. So for the second one, the same type of thing happens here. So we'll have h to be negative 5, k to be 2. This time 15 is not a perfect square, but you still take the square root of it, and so therefore r is going to be the square root of 15. And your center is negative 5, too. And then in the last one, they try to trick you a little bit. You just simply have to add the 9 to the other side. You don't want it set equal to 0, so if you add 9 to the other side, when you go to do the x squared, that's really x minus h. H in this case is 0. And so if therefore your center is 0, 2, and your r is equal to 3. Easy peasy. Now, for example 2, it says find the equation of a circle whose center is 2 comma negative 4 and the radius is 5. Using that formula we had for the standard form, we're going to do x minus h, in this case is 2, y minus k, which in this case is negative 4, so we end up with y plus 4, and then the radius is 5, so we'll square that, we get 25. Your final answer looks like this. For example 3, to write the equation of a circle with point 4 comma 5, on the circle, and the origin is its center. So we know h and k is going to be 0, 0. we need to know the radius. In order to find the radius, we're going to find the distance between the center and the point on the circle. So in order to do that, we're going to use our distance formula. We're going to use 0, 0 as our second point. So if we plug in our x's and y's, this is the formula you end up with. So you find out that r is equal to the square root of 41. So plugging it into your standard form, we end up with x squared plus y squared equals 41. So pause the video, take a moment, and try this example. For example 4, it says to write an equation of a circle whose endpoints of a diameter are 5, 4, and -2, -6. That means on your circle, when you're graphing it, 5, 4, which is here, and -2, -6, which is here. This is the diameter of the circle. So you need two things to write the equation of a circle. You need the center, and you need the radius. To find the center, you have a line segment. So you want to find the middle. Just like your warm-up that I gave you earlier today, you will use the midpoint formula to find the middle of this line segment. This is going to give you your center. And then you can use the distance formula in two ways. You can either find the distance between the center and one of the points. It doesn't matter which point you choose to find the distance between. This will provide you your radius. Or you can find the distance between the two endpoints. This is going to give you your diameter. So once you get that distance, you'll have to divide it by 2. It doesn't really matter to me which way you do it. So I'll first find the midpoint. Using the midpoint formula, I get a center of 3/2, -1. And then I'm going to use the distance formula between, looks like I used 5, -2 and 4, -6. So once I find the distance between these 2 points, that's just giving me the distance formula in the numerator. That will be the diameter. However, I have to take that and divide by 2, and that will give me my radius. So now, when I plug it into the standard form, I'm going to have x minus 3/2 all squared, plus y plus 1 all squared for my h and my k. And then if I square my radius, the square root of 149 becomes 149 divided by 2 squared is 4. And so here's my equation. So go ahead and pause the video, take a moment, try this example now. Next example says to find the x and y intercepts of the graph of the circle given by the equation. So you know your circle has a center of 4, 2. You know the radius is 4. Your job is to find the x and y intercepts for where that would occur. So just like in Algebra 1, in order to find the x-intercept, you set y equal to 0. So when we do that with this equation, you have an equation you can now solve. So you will square your 2 to get 4, subtract that from 16 to get 12. You'll take the square root of both sides, just don't forget to include your plus or minus. And then when you do that, you'll get plus or minus 2√3 once you simplify square root of 12, and then you add 4 to both sides. So if you want to turn that into a decimal, you can use your calculator to figure out where that would be on the x-axis. To find your y-intercept, you do something very similar, except this time you set x equal to 0. You'll plug it in, and you'll solve. So if you were to actually graph this on Desmos or your calculator, you can see here that the y-intercept truly is 0, 2, and then these as decimals are somewhere between 0 and 1, and 3 and 4. So you have your two x-intercepts there. All right. For example 6, it says find the center and radius of the circle with the equation x squared plus y squared minus 4x plus 8y minus 5 equals 0. This is what's called general form of the equation, so we cannot immediately see the center or the radius. And so what we're going to have to do is turn it into its standard form. Just like when we have a parabola, where we have it in a different form. Maybe we'll have, like, for example, 2x squared plus 4x plus 1. This would be the general form of a parabola, but we turn it into what's called its vertex form by completing the square. We'll have to do the exact same type of thing here. So we are going to complete the square, but unfortunately we are going to have to complete the square twice. So the first thing I'm going to do is I'm going to move the 5 to the right-hand side to get it away from my two sets of variables. I'm going to reposition my 4x so that it's with my x squared, and I'm going to reposition my 8y so that it's with my y squared. Now I'm going to complete the square with the first two pair for my x squared minus 4x, and then I'll complete it again for my y squared plus 8. So when I do that, to complete the square for my first pair, I'm going to take half of negative 4, which is negative 2, and square it. That's going to become plus 4. I'll add that to the right-hand side as well, so I can keep my equation balanced. And then I'll take half of 8 and square it, which is 16, and I'll also add that to the right-hand side. You now have two perfect square trinomials. This is your first one, and this is your second one. You can factor each of those into their binomial square. And then on the right side, when you add 16 plus 4 plus 5, you get 25. You now have this in general form, standard form, which means you can find the the center very easily, which is 2, negative 4, and the radius is 5. So you would go to 2, negative 4 in the graph. You would go up 5, down 5, right 5, and left 5, and then you'll connect your dots. Alright, pause the video, take a moment to try this example. And then that is it for this video. Okay?